the fact that there were two terms in here. That was the problem. Because if I only have x to the 10th, I'm not going to substitute for anything. The problem was here because I had two terms, and taking a binomial to the 10th power will make me sweat for a while. And I will have 11 terms. And I don't want to do this. So what do you think the problem is here? Look at this function, decompose it in your mind, and say, oh, I know, the problem is this.
Well, 1 plus cosine.
Absolutely, this is the problem, because the square root of a plus b is stuck. Exactly, that is the problem. So I'm going to say let u be 1 plus cosine t. What is the next step? Mandatory step. Absolutely mandatory step. What is it?
Find du.
Exactly. Without du, I can't continue. And du is?
Would it be negative sine t dt?
Awesome. I have sine t. I have dt. The tiny little thing that I don't have, it's a piece of cake. I multiply by -1 twice, which is 1. So this piece and this piece and this piece, they're all du. How do I replace this? Or by what will I replace it? I cannot have t and u in the same integral. Not allowed. So I'm going to put a triangle and jump over all this to page 7 and start with the triangle. And I have a minus in front. And what will you tell me to write?
Square root of u.
Yes, or u to 1/2 to be ready. And what else?
And du.
Exactly, 1, 2, 3 du. Awesome. This is gibberish. This is a piece of cake. Because this is negative u to 3/2 over 3/2 plus a constant c, and it's done. I don't know what to do with that. So the substitution helped to simplify my integral, basically my function. So this is negative 2/3. U, I have to go back to it. I have to. 1 plus cosine t to 3/2 plus a constant c. And now it's done. So basically the substitution is for the function. I've rearranged the function in such a way that I can determine the integral. Basically the antiderivative. I don't know what the antiderivative of this is, but this is a piece of cake. I'm adding 1 to the power, and I divide by the same number, and then I flipped into 2/3. I plugged back in u, and it's done. Well done. Any questions on this one? You feel a little bit better? Okay?
Yes, for sure.
Good. So let's look at anything else. You choose.
Hard to see that. What about 19?
19 it is. Let's continue with 19. Where is it? Cosine, the integral from cosine to the 3rd of theta times sine theta times d theta. Great pick. Good. So let's say let t be. Obviously, here it's a little bit, maybe slightly more difficult. Why? Because I'm looking at this product and I have to decide which one is more difficult, right? So here I knew that that was a problem. the difference of two terms. Here, I knew that the problem is 1 plus, so the sum of these two terms. Why? Because they are inside the square root, inside a power, like this one. Two terms inside a power. Two terms inside a power. The square root is a power. What power? 1/2. Here, I'm going to look and see, well, both of them are easy, sine and cosine. However, this one is the power 3. So I prefer, I'm thinking of saying let t be cosine theta. This will automatically be changed into what?
E to the power 3.
Very good. However, I have to have dt in the problem, or maybe a little constant that needs to be adjusted, but it has to be in the problem. What is dt equal to?
Negative sine theta times d theta.
Exactly. It's right here. There is a little adjustment to be made. Who cares? I put a -1 in parentheses and -1 in parentheses outside. I'm multiplying twice by -1. So then I have the negative in front, and please dictate the new integral, basically the new function.
Negative.
yeah.
Oh, sorry.
You go ahead.
Oh, is it gonna be cosine 3 or t cubed? Sorry,
Yes,
dt.
that's it. Negative t to the 4th over 4 plus a constant c. I have to go back. Negative cosine to the 4th of theta over 4 plus a constant c. The substitution helped tremendously. How do I know? Later on you will, but at this point, how do I know what function is the antiderivative of this product? Step by step, I picked a substitution. I found the correct dt. I rearranged the whole thing, and I changed it into this, which is a piece of cake now. But I have to go back to the original variable. The function, or the integral, if you want to say, was given in theta. The answer has to be given in theta.
Could we also list that as 1/4, or would it be
Yes,
better? to list
negative
it-
1/4 in front. Yes, negative 1/4
Is
cosine
one
to the.
better than the other?
It doesn't matter. It's a very good question. So remember when I need this,
Mm-hmm.
this is better than that.
Right.
But from this point on, I'm not doing anything else with this. So if I write it like this or like that, it's pretty similar.
Okay.
Good. Next one. Now, do you want to choose one and work on it? So I'll wait. Or can I choose one for you?
Maybe we could like, yeah, you could choose one actually.
So I like to choose 22. So let's take a minute and work on it. So 22 is the integral from sine 1 over x squared dx. And I'll get a bottle of water. I'm not doing anything. I'm back. Can anyone tell me what you used as u?
Thank you.
I should sine of or u or sine of x.
So what was u? What did you select as u?
I'm thinking x to the negative second.
So x squared is not a big problem.
No, just having it like
A
the
function,
sign also isn't a problem.
no, but the
It's
function
the one
inside
over x.
sine is the problem.
Yeah.
Oh, I forgot that that's a function. Okay.
So 1 over x.
Exactly.
So u is 1 over x.
So what will be du?
Du would be negative 1 over x squared times du or dx.
Perfect. Here it is. Dx over x squared is missing a tiny little adjustment. Good. So there is a negative outside. Can anyone dictate the new function, new integral?
Be sine of u
Yes?
times du.
Yes? That's it. Sine u du. Don't you like it? Do you prefer this or you prefer that?
I prefer the right side.
Of course. Which function prime is sine u?
Cosine u or negative cosine.
Yes, so then I will write just cosine plus a constant c because cosine prime is negative sine. I cannot leave it in u because the integral was given to us in x. So I have to go back and plug it in. Very good. So what have we learned now from this integral? So from the previous one, it was the power that told us what to do. On the previous one, the hint was two terms under a power. Here the hint was two terms under a power. But here the hint was a function inside the function. If you say sine x, I'm fine with it. But if you say sine 1 over x, I'm not fine with it. Why? Because it's a function inside sine. That's why I'm not okay with this. I'm okay with this, but not with this. So that's why we denoted 1 over x by whatever. Awesome. Okay. 25. 25 is natural log x squared over x and the integral dx. What bothers you here?
Definitely natural log x.
Yes, because it's inside the power. So I will say let u be natural log x. Let's see if we can find du with a minor adjustment. The minor adjustment will never be a problem. But du pretty much has to be in there for this to work.
Dx over x.
Yes, 1 over x dx.
Yeah.
So what is the new integral?
U squared times du.
U to the third over 3 plus a constant c, and I have to plug it back in. Natural log x to the third over 3 plus a constant c. Let me write it one more time here because it's not very clear. Natural log x, everything to power 3 over 3 plus a constant c. Awesome.
Hold on. Can you stop for a second?
Yes.
Okay. So I got the u and du. So then we're plugging back in. So it's
U squared
natural
du.
log. So it's hold on. It's first u squared du.
Is that okay?
Yeah, which then, okay, and then you made that u cubed over 3, okay. Plus c, and then you're plugging the natural
Yes.
log.
Yes. Because the integral was given in x, the answer has to be in x.
Is that that's a 3, not a 2, right? Above the natural log in the parentheses? No, I'm looking over on the side, but yes, it's there, okay. Because I thought that was a 2, and then I was like, wait, where'd the 2 come from? Okay.
Good.
So,
I'm not going to ask if you had enough. You choose. And I'll know when we stop. Please choose whatever you want.
23.
You said 23. Very good. Awesome. Let's work on 23. The integral from a plus bx squared over the square root 3ax plus bx to the third dx. Perfect pick. Good. I know this is not a scientific way of choosing, but it triggers your memory on what we just looked at. So what do you think is the problem here?
Looks like the square root.
Yes, the quantity under the square root. Because again, the square root of a plus b stuck. That's why. Good. So let's use y equals 3ax plus bx cubed. Remember, a and b are constants. We can only have in this class a function y of one variable only. And as long as I have dx, I know the variable is x. A and b are gibberish parameters. Good. So if we use this, I have to find dy. dy has to be 99% in the problem. Otherwise, I get stuck. A minor adjustment is always fine.
Is that 3a plus b times something?
plus 3b
3b, yeah. X squared
squared.
times dx.
Exactly. I'm going to factor out a 3. So dy equals 3a plus... I just said I'm factoring out a 3.
Can you put it right back?
My hand wrote faster than my brain dictated. Good, so we factored out a 3. Good. Look what we have at the top.
You just replace those basically.
So a plus bx squared is in the problem. Of course, dx is in the problem. The minor adjustment is 3. I multiplied the top by 3 and I multiplied the denominator by 3. This product is 1. I did not change the problem. Now I would like you to tell me what this will be replaced by. And I would like to know what this will be replaced by.
So it would become dy over the square root of y.
Exactly. That's it. How brilliant. So 1/3 in front, the integral from dy over the square root, 1 over the square root of u. I'm going to write it as u to negative 1/2 to make my life easier. Oh,
What? Hold on, why are we doing u?
of course, I don't know. No answer for that. I take the 5th on that one. So, again, we replaced 3a plus bx squared times dx, 3a plus bx squared times dx by dy. We were left with, so this is the square root of y. 1 over the square root of y was replaced by y to negative 1/2. Why? Because I wanted to get it done. So then I increased the power by 1. negative 1/2 plus 1 is y to 1/2. Of course, divided by the exact same number plus a constant c. And I have to flip the 1/2. So I get 2/3. The square root of y. 3ax plus bx cubed plus a constant c. Well done.